This is a walkthrough of the Maestro Challenge, Chapter 2. Basically, we're going to walk through how you set up your environment to run Symfony control plane and set up the necessary files for the truck fleet scenario. So basically, in the truck fleet scenario, we will simulate a bunch of trucks docking to a field office, and we will create the Symfony target object to represent those trucks. And then you go from there, right? That's just to set up the starting point of your environment. Once you have those targets created, you can start to deploy Symfony solutions to those targets. So this part of the video is really about how to get started, how to get your environment ready for the exercise. And basically, everything we walk through is from this document. So if you prefer to read the document yourself, you're welcome to do so. But here I'm going to just walk you through all the steps. And the first step we need to go through is to install Symfony itself. We have command line tool for you to install Symfony. So you just copy this and you just run this command. This command should work on Linux, Mac OS, as well as WSL on Windows, as I'm using. If you are using a pure Windows system, you need to use a PowerShell script. And please look at the Symfony repo for that PowerShell script. But the experience is the same. Basically, you copy this line, you just install this command line. So currently, I already have the latest version installed. So basically, it will just try to apply updates to this version. So now the Maestro command line tool is installed. And to validate you have the latest version, you can do Maestro version. Somehow my screen is flaking, but hope it's okay. So the version is 48.32. By the time of Hackathon, probably we'll have 48.33. So just make sure you run the Maestro tool like this. This script will download the latest script and update your Maestro environment. So once you have this Maestro tool installed, you can use Maestro to install Symfony. You can simply do Maestro up. So when you do this, Maestro will look at your current kubectl config to use your current Kubernetes cluster and put Symfony onto that cluster. So before you run this command, you need to make sure that your kubectl context is the one you want to use. And if you don't have a kubectl context established, or if your kubectl is pointing to a minikube, Maestro app will try to install Symfony onto a minikube as well. This is what I have. So basically, I will try to run Maestro up. And now it says I'm not connected to Kubernetes cluster. It asks me what I want to do. So I'm going to choose 0 in this case. I'm going to install a minikube if necessary. Then it will create a minikube cluster and install Symfony on it. This will take a while. Let me go back to the repo. So instead of using Maestro up, you also have the option to use Helm install. Let's say if you have an AKS cluster or K3S or minikube, you can use the Helm install, and you can pick the version to use. Again, currently it's on version 48.32, but probably you will need 33 when the hackathon begins. So let's go back to the terminal. So we'll wait for this to finish, then we'll resume. In the current version of Maestro, once it installs the Symfony API, if you try to access the Symfony API REST endpoint to see if the API is ready. However, on Minikube, this check will not pass because Minikube cannot assign a public IP to the load balancer service. So in this case, we'll just press Ctrl C to stop the script. But you should see the Symfony should be installed correctly. You should see a bunch of Symfony services. I'm sorry, the screen is flicking, but you can see the Symfony is installed. So in this case, if you don't wait for the API to finish, you won't be able to use the Symfony REST API, but you are still able to use kubectl to interact with Symfony. And this is what we are going to use. So we are good to go. Symfony is installed. And if we go back, I will skip this part. So basically, once you have the Symfony installed, you can try the basic operations, like create some solutions targets and create some instance to deploy the solution. There are some links that you can refer to. But I will skip this part for now. Next one is to deploy an MQTT broker. This is because in this exercise, we will mostly be focusing on using the remote agent, right? So basically, the Symfony control plane is what we running on the Kubernetes cluster. And then you can run a remote agent anywhere you like. And you can connect the remote agent through a MQTT broker with the control plane. So for testing purpose, we'll set up a local MQTT broker. And we already have the configuration file created for you. So basically, you just need to copy this. And if I go back, paste this. And this will create a Mosquito MQTT broker for you. Actually, I think on this cluster I already deployed before, but it doesn't matter. You should see this Mosquito service. It's a load balancer service. As you can see, it cannot assign this public IP because of Minikube. So to make this available to your local agent, you need to use Kubernetes port forwarding to forward port 83. So I think we have the instructions to do that as well. So here you need to do the port forward. So basically, after you run this, you can see this on your local host port 1883 is forwarded to this Mosquito service. This will allow your agent running on your own machine to access this broker through localhost. Again, this is just because Minikube cannot assign this external IP, so we need to do this port forwarding. And we need to keep this console running for this port forwarding to work. So I'm going to start a new console and continue with the rest. So this one is doing port forwarding. I'm going to the same folder. Okay, now I'm back to this folder. So now we have the Symfony installed and we have the MQTT broker installed. The next thing we want to do is to deploy the truck template. So basically, we have a bunch of truck templates as Symfony catalog object. So these are just templates for you to create your objects. You don't have to use this. You can manually craft your target object by yourself. But in a lot of cases, if you want to standardize object creation, you can use catalog to define standardized templates for your user to use. Let's just look at one of the templates. If we open the truck template, you can see we have 4 types of truck. One is the mock truck. This is like a toy truck. Then we have a flatbed truck, a box truck, and a freezer truck. And if you look at the mock truck, basically this catalog defines the template of this truck. Basically, it defines the name of the truck and it defines the topology. And this is the key part of the target. So basically, target definition, it maps a component type into a provider. As you may know, a Symfony solution, which represents an application, may contain one or more components, and each component is associated with a type. And when that solution is to be deployed on a target, Symfony use that component type to look for the target provider to use. And this mapping is defined by the target binding topology. Essentially, this is saying, if I see an instance component type, I will use a mock provider. And usually there's a provider configuration associated with this as well, but the mock provider doesn't need any configuration, so that is omitted here. But if you use other provider, you need to supply the provider configuration here as well. And for the target, you can associate any properties. This is literally anything, right? You can associate any like digital twin-like properties to your target object to represent anything you want to describe the truck. So these are the templates, and if we apply these templates, I need to go back to this. Basically, to apply all these 4 templates, you just need to run this command. I'm going to copy this and run the templates. And so once I do that, if you do get catalog container, you can see the 4 catalog containers. And each catalog container can contain multiple versions. So if I do kubectl get catalog, you can see I have one version of each catalog container. So basically I have a food truck container, and in the food truck I have a food truck v1 catalog. So now my template is ready. The next thing is to provision the workflow. So as we explained, right, in this scenario, we're trying to simulate when a truck pulls up at a field office, we will run a workflow to register that truck as a target object on Symfony. So this is done by this workflow. Let's look at this workflow first. So we're going to look at the workflows docking. And this workflow is actually quite simple. It contains a single stage called a register. This register is using what we call a materialize. Basically, what materialize does is to take a catalog object and extract the spec contained in the catalog and create the corresponding objects. Remember for instance, the box truck template. We have this catalog and we have the target spec embedded into it. So what the materialize does is to extract this target spec and create the target object. So if I go to the workflow definition, you can see essentially this is what it does. And this workflow takes one parameter. Basically, when you trigger this workflow, you can supply a truck template to select which template you want to initiate. And by default, it will use this mock truck v1 template. And this is the workflow. Let's define this workflow first. If I go back to this document, to provision this workflow, this is what you need to do. Let me clear this out. And if I get campaign, which is Symfony's definition of a workflow, you can see this workflow is provisioned. And now we can actually initialize the activate the workflow to create different trucks. But I think before that, we will deploy the Symfony sample portal. So Symfony has a sample portal called Opera, and you can use this supplied deployment to deploy Opera onto your cluster. So I'm just going to copy this and deploy this. And once this is deployed, you will see Opera service, which is also load balancer, and because of the Minikube, you cannot get a public IP. So we need to do another port forward to forward port 3000 into this into local machine. So if we go back, we should have another port forward command. We just do this, okay? And you also need to keep this one running. So let me rearrange this. So I'm going to start another terminal and make this smaller, maybe. Oh, sorry, wrong key combinations. Okay. And go to the red folder. Okay, so we have two port forward going. One is for MQTT broker. The other is for the Symfony portal. And before we go forward, let's just connect to the portal just to make sure the portal is actually working. So if you've been using the portal for a while, the authorization token may expire. So in this case, you just click on sign out. Then you do a sign in. Basically, the username is admin. There's no password. You can just sign in again. Then everything should be okay. So now, as we have this portal launched, we will simulate a bunch of trucks docking to the field office. So when each truck docks, we will activate the workflow to create the corresponding target object. And the way to do this is to create activation objects. So in Symfony, the workflow definition is a campaign. And to run the campaign, you need to create an activation object. For instance, this activation object is saying, I'm running this docking campaign, and my input, remember the campaign expects a parameter. I'm saying I'm going to use the mock truck template to run this. So you can create these files yourself, and we also provided 4 activation files, so you can directly run. But once activation is created, it's immutable. You cannot update the activation because activation serves as a record of the workflow run. If you want to rerun the workflow, you will have to create a new activation object, or you can delete your current activation object and recreate the object. So remember, activation object is just once, right? So let's go back to the terminal. I'm just going to activate the activations. So first I'm going to keep Symfony workflow. I will do the mock truck activation. So this will trigger the campaign with mock truck template. Then I will do the flatbed. I will do the box. And then I will do the freezer. No. It's called reefer. Okay. Okay. Now I've activated the workflow 4 times, and each workflow will create one target object. And if I do kubectl get target, you can see this the target objects created by those workflow. Again, this is just to show you how you can use a workflow to automate the target object creation. You can certainly to directly create a target object yourself. Basically, you just create a target YAML file, then you just apply it. It will be registered with the system. And if I go back to the portal, if I go to targets, you can see this 4 target objects has been created. And you can actually look into the JSON definitions of the target file. So now we have the targets ready. Actually, from here, you can start to define your solutions, which is your application. Then you can use instance object, which essentially is a deployment. You can pick which solution is deployed to which targets. But we are going to skip that for now. Let's continue with this document. So we've already run all the targets. We've seen the targets on the portal. And the next is we want to create a Symfony agent configuration. Again, here the target is to run this Symfony agent. So to run this agent, first we need a configuration. So basically this configuration needs to tell the agent where the MQTT broker is and what the target it represents. And if you use the config only switch, it will generate the configuration files only instead of launching the agent directly. So here I'm going to use this Maestro agent command to generate an agent configuration file, and just to show you how that file works. So if I go back to this, here I'm going to use a custom build of Maestro. When you are in the hackathon, you should just do Maestro. The latest should work. But currently I'm using a temporary build. Actually, let me start another console. I don't think this will work. I'm just close this. I'm just going to reuse this. I'm going to go back to a different folder where my custom build exists. So I'm going to use a local Maestro for now, but again, in the actual hackathon, you don't have to do this. You can just do directly Maestro agent. So I need to point to the MQTT broker. In this case, because I'm using Minikube, remember I did this port forwarding. So I just need to connect to localhost 883. My MQTT client should be unique to my target. In this case, I just say this is a demo truck. And my target name will be actually a demo truck. However, in reality, this target name should match with one of these, right? Should match with the actual target object name on your system. Here I'm just using a dummy name for now. And use the -- config only flag so that it only generates the configuration file. If I run this command without this, it will still generate the configuration file, but then it will launch the agent automatically. But here I want to customize the configuration file before I launch it. So I just use config only for now. Now it saves the configuration file under this folder. So I will just bring it up. And I'll bring it to the window. So this is the configuration file it generates. Essentially, to run the Symfony binary as an agent, you need to specify, actually this is not right. This should be true. Double check the configuration. If this is not set, you need to set it to true. And a key part is this. This is the target name your agent represents. Your agent actually can represent one or more targets. So in this case, I'm just representing one target. If you represent multiple targets, you can just comma like another target, etc., to have multiple targets. But in this case, we'll just use one target. And also, you can see on the providers configuration section, for each of the target name, like a demo truck, I'm saying what type of target providers it should use. So basically, when this agent runs, whenever it receives a component from Symfony to deploy, it will just use this provider to deploy it. And if you want to use another provider, let's say instead of a mock provider, you want to use Docker provider, you should just update the provider configuration. Docker provider doesn't need any additional configurations either, so you can leave this empty. But if you use some other providers, like a script, then you have to supply additional settings, like the script folder, etc. You can look up the Symfony repo for samples of doing that. So here I'm just going to change back to mock. So this is the configuration file. In the hackathon exercise, the idea is that you will pick a built-in provider, like a Docker provider, or you can bring your own providers. In other videos, we'll show you a couple of ways of bringing your own providers. But you can also go with the mock provider, which doesn't do anything, but it allows you to experiment with the workflow. So this is a demo truck. So once you are satisfied with that configuration file, you can actually launch the agent using that configuration file. If I go back, so basically it talks how you can customize the configuration file, which we just talked about. Then basically you can launch the Symfony API process with the configuration file of your choice. Then you can use a debug switch to observe the debugging information. So I'm just going to do Symfony API, then C configuration file. I use Symfony agent demo truck, and I will use L-debug to see the debug information. So this will run the agent in your console. So you should keep this running. So this will be the agent representing your target device. In the real deployment, probably you want to deploy this agent either as a part of the system image or as a daemon that is launched when the system starts, so that you always have this agent available. But for our testing purposes, it's perfectly okay to run this in the console, because then you can see all the output and observe what's happening. So this is it. We installed Symfony onto the local Minikube. We set up the MQTT broker. We set up the Symfony portal. We defined a bunch of truck templates, and we activated the docking workflow and created 4 target objects. And then we generated an agent configuration file, and then we launched an agent using that configuration file. So this is the starting point of the SDV hackathon, and we will go further in the hackathon to experiment how you can make a custom provider and how you can do actual deployments to these agents. Thank you.